Hello 8th grade students. Today we are going to continue our learning section on the topic of motion, and especially through the video we will learn about uniformly motion in a straight line or UMSL. The basic competence of this lesson is to analyzing a straight line motion, the effect of force on motion based on Newton's laws, and its application to the motion of the objects and living things. Everything in our world moves. Even stationary things such as your house move in relation to the sun or to other stars. The motion may be purely vertical, thereof a falling stone, purely horizontal, thereof a car in highway, or slanted, thereof an airplane rising at an angle from a runway but must in a straight line. So what is uniform motion in straight line or UMSL? Uniform motion in straight line or UMSL is a motion in a straight line where the position of an object changes uniformly in a period of time. Motion with constant velocity or no acceleration, and the variable are distance d, speed v, time taken t, and the relationship between speed, time, and distance is v equals to d over t, t equals to d over v, and d equals to t times v, with v is a constant speed. Next, the graph of uniform motion in straight line. When the car moves with constant speed, so the graph of UMSL based on the illustration are distance time graph, which is a straight line, indicate a constant speed. The steeper the line, the faster the object is going. The speed can be found by getting the slope. Next, velocity time graph is in the form of straight line parallel to x-axis or time axis because the speed of the object doesn't change. Next, the last, acceleration time graph is 0 because the speed is constant, so the change of speed is 0 and the acceleration is 0. Example 1. Someone drives the car with constant speed 15 meters per second. A. Calculate the distance at 4 seconds and 5 seconds. B. Time taken to complete 3 km distance. The solution. Given v equals to 15 meters per second, ask A. Distance when the time is 4 seconds and distance when the time is 5 seconds. B. Time when the distance is 3 km or 3000 meters. Answer A. For time 4 seconds, so d equals to v times t, so 15 times 4 equals to 60 meters. For time is 5 seconds, d equals to v times t, and 15 times 5, so the answer is 75 meters. B. T equals to d over v equals to 3000 over 15, so the answer is time equals to 200 seconds. Look at the graph. An object moves like a graph above. Calculate the distance traveled at A. The time is 4 seconds. B. The time is 10 seconds. And C. The time is 1 minute. The solution. Given v equals to 5 meters per second or constant velocity, ask A. Distance when the time is 4 seconds. B. Distance when the time is 10 seconds. And C. Distance when the time is 1 minute or 60 seconds. Answer A. For time is 4 seconds, so d equals to v times t equals to 5 times 4, so the answer is 20 meters. B. For time is 10 seconds, so d equals to v times t equals to 5 times 10, so the answer is 50 meters. C. For time is 60 seconds, so d equals to v times t equals to 5 times 60, so the answer is 300 meters. Next, the formula of UMSL if the initial position of the object is at x0. The formula is xt equals to x0 plus v times t, where xt is the final position, the unit is meter, x0 is the initial position or position of reference point, the unit is meter, v velocity or speed, the unit is meter per second, and t is the duration of time or second. Problem 1. Jason is sitting on his motorcycle 100 meters from a police station. Then he drives his motorcycle away from a police station at constant speed of 15 meters per second for 1 minute. Calculate the position of Jason now and distance traveled. Given t equals to 1 minute or 60 seconds, x0 equals to 100 meters from the police station, and v is 15 meters per second or constant speed. As a xt or final position, b d distance traveled. Answer a xt equals to x0 plus v times t, and 100 meters plus 15 times 60 seconds equals to 100 meters plus 900 meters. So the answer is 1000 meters. There is the Jason's position from the police station. B. Distance travel. D equals to v times t. The velocity is 15 meters per second and the time is 60 seconds. So the distance travel is 900 meters. Problem 2. Car A and car B are separating 420 meters apart. Both of them move closer to each other at the same time with the speed of 40 meters per second of car A and 10 meters per second of car B. Determine where will they meet. First, draw the illustration. The solution. Given distance from A to B is 420 meters, velocity of A is 40 meters per second, velocity of B is 10 meters per second. Because the time A equals to time B, so dA over VA equals to dB over VB. So x over 40 equals to 420 minus x over 10. So 10x equals to 1680 minus 40x. So 50x equals to 1680. So x is 680 over 50. So the answer is x equals to 336 meters. So the meeting point of the two cars is 336 meters from the starting position of car A. Problem 3. A car A is chasing a car B with a constant speed of 60 meters per second. A car A is behind 600 meters of a car B in a straight line. At that time, a car B drove with a constant speed of 30 meters per second. Then the time needed to catch up a car B is... The first step is draw the illustration. The solution. The distance of car A to the final position of C is dA. So dA equals to dB plus 600 meters. Because the time A equals to time B equals to T, so based on the formula of UMSL, D equals to VA times T equals to VB times T plus 600, and move closer VB to VA. So VA minus VB times T equals to 600. So T equals to 600 over VA minus VB. So 600 over 60 minus 30. So the time is 20 seconds. Some example of UMSL in daily life. Number 1. A car going along a straight level road at a constant speed. Number 2. A train going along the track at a constant speed. Number 3. An airplane crashing at a level height at a constant speed. And number 4. A vibrating spring in sewing machine. Next, pause the video now and do the exercise number 1 and number 2. I think that's all for me. Thank you for your attention and God bless you.